Hi, welcome back to this channel. In this video, we're still in chapter 10, carboxylic acid and its derivative. This video mainly we are focused on the chemical properties of our carboxylic acid. So first, basically we will focus these two, neutralization with a base and reaction with electropositive method. So basically these two reactions, and where is the alkyl group, sorry, not the alkyl group, sorry, the carboxyl group will break the bond between O and H. Okay, and then second part we have the reduction as we discussed in the previous video. Reduction of carboxylic acid only will produce primary alcohol. And then here these four we will consider they are carboxylic acid derivative, at where the bond will break between O carbon and OH. Okay, then next one we will discuss about the reducing properties of methanoid acid, because in this case we notice that methanoid acid is a very special structure at where the left hand side here they seems like have the functional group of the aldehyde carbonyl. Okay, then the other side at here they have the carboxyl group. So this makes the methanoic acid sometimes can behave like aldehyde, sometimes can behave like carboxylic acid. Okay, this is a table that I combine together with the alcohol, phenol, and also carboxylic acid. As we know in the part of the acidity, we say that these three are acid. So now we are comparing. For the alcohol, they only will react with the reactive matter. But for the phenol, they will react with reactive matter and also hydroxide. But for carboxylic acid, reactive matter, hydroxide, and also carbonate. Okay, so from here again, we make the conclusion, carboxylic acid is the most acidic. Okay, so now we will look at how we're going to answer the question related with the reactive matter, hydroxide, and also carbonate. Okay, let's start with the tutorial question number 8. So number 8C, we can see here there is an NaOH. So and then here we have O negative and Na plus. Okay, so roughly we will know that the structure of the C consists of CH3, CH2, CH2 we maintain, and then this part COO negative and Na plus. As we know that just now we mentioned that the bond will break between the O and H. So you imagine that you will take out the Na plus and then you will replace the hydrogen. Okay. So for the questions G, we can see there is NaOH, and then this is carboxyl group, and then this is primary alcohol. So if you still remember, based on the table above, we say that NaOH can react with phenol and also carboxylic acid. So therefore, this is alcohol, so no reaction at this part. So we will draw back the cyclic part. For the COOH will become COO negative and Na plus. While for the alcohol part, CH2OH, we will maintain the same because of there is no reaction between alcohol and also NaOH. So F, when we can see the lithium aluminum hydride in dry ether, this is the reduction. So we know that reduction of carboxylic acid will produce primary alcohol. So CH3, CH2, the alkyl group maintain. The COOH will become CH2OH because we want to change it to become primary alcohol. Now let's proceed to tutorial question number 9. We already discussed P, X, Y, and Z in previous video. So now we will try to identify the reaction that carry out with the sodium. And the bond we want to focus these two type of reaction first, the bond break between O and H, and also the reduction process. So from here we notice that the W and also this Q, because it's related with the lithium aluminum hydride in dry ether, which is the reduction. So come back to here, so we draw the structure of W first. We draw back the cyclic part, the COOH will become COO negative and then Na plus, because sodium can react with carboxylic acid. So again, when we see this is the lithium aluminum hydride, we know this is the reduction process. So as usual, we draw back the structure of the cyclic part because there is no changes. So no functional group involved. So COOH undergo reduction, carboxylic acid undergo reduction, will form primary alcohol. So the COOH will become CH2OH. So from here we can see lose oxygen and gain gain hydrogen and lose oxygen. Okay, in this slide we are showing the summary for the formation of the carboxylic acid derivative, where basically the carboxylic acid is break the bond between the carbon and the OH, and where the OH group will be replaced. Okay, first, it will produce acyl chloride if the carboxylic acid react with PCl3, PCl5, SOCl2 in pyridine. So mainly the observation that we can see is the white film. So this white film basically is referred to the HCl. Okay, so what makes them different? So you have to alert here. If you can see another side product, which is the SO2, means that the reagent used is SOCl2 in pyridine. If you can see the another side product, which is the POCl3, so we know that this is the reagent used is PCl5, while the another side product for PCl3 is H3PO3. Okay, for this one you can refer to your notes. Okay, so we already settled for the first one. Like we mentioned here, the OH will be replaced by the Cl. So next one, we are going to produce acid anhydride. So when we want to produce acid anhydride, there are two reagents that we can use. We can react carboxylic acid with carboxylic acid, then we need the P2O5 as a solvent. If we react carboxylic acid with the acyl chloride, then we are going to use pyridine. Okay, so in this case, the H will be taken out, the Cl will be taken out. So we will get the acid anhydride. So if you can see, there is C double bond O, O, C double bond O. So this is acid anhydride. So for the ester, as we already know, ester have the pleasant smell. And then the formation of ester always is from carboxylic acid and alcohol. So the one which from the alcohol, the bond is break between the O and H. So that's why we will get the functional group C double bond O, O. Okay, then next one is the carboxylic acid react with the amine of ammonia or amine with the heat condition, which will form the amine. Okay, C double bond O and H2. So basically, these are the summary for the for the formation of carboxylic acid derivative, which include the acyl chloride, acid anhydride, ester, and also amine. Okay, without wasting the time, let's continue with the tutorial question number 8. CH3 is the alcohol, and then we can see this one is the COO, which is the ester. So from here, we know that we will separate the structure ester to two parts. Each part will consist of one oxygen. So it is very obvious that this part have one carbon, which is from alcohol. So this part will be from the carboxylic acid. So the structure D is CH3CH2 COOH. Okay, so this is the structure for the D. Now let's proceed to question E. So try to focus where's the difference between these two parts. The OH is replaced by the Cl and then produce HCl and with the side product SO2. So means that in this case, the reagent E must be very specific and we only will accept SOCl2 in pyridine. This is the only answer that we can accept. PCl3 and PCl5 cannot be accepted due to the presence of SO2 in this question. However, let's say in this question, they didn't show us the SO2. They just give us this equation. So if in this case, your compound E can be SOCl2 in pyridine, accepted, can be in PCl3 and as well as PCl5. All these three can be accepted if there is no other side product showing in the question. Okay, now we still continue with question number 9. This is the reagent, the carboxylic acid that we focus in this question. And then in just now and previous video, we already discussed question. We already identified X, Y, Z. We know the P, we know the Q, and we know the W. So now we are going to continue with R, S, T, and U. So basically again, this R, S, T, and U is trying to relate with the topic of carboxylic acid derivative. Okay, so we start from the R. When we see the PCl3, so we know that the OH bond, okay, will be break down and then replace with the Cl. So want to remind again, if the carboxylic acid going to form the carboxylic acid derivative, the bond is break between the carbon and also the OH. So we will take out the OH and replace by another structure. Okay, so S, when we see this is the hydroxyl group, so it's alcohol. So we know that again, the carboxylic acid C double bond O. And then for the alcohol, the bond will break between O and H. So we're going to connect it with oxygen and then CH3. Okay, so next one is the NH3. So like previously we mentioned that NH3 is base, carboxylic acid is acid. So acid and base react. Basically, they will produce salt. So we will have COO negative. H will be removed and then replaced with again by the base NH3. So it become NH4 plus. So when do the heating, the U, the structure U will be over here. It will become the amide, which is C double bond O and H2. So basically, I think we already discussed all the chemical properties that can, chemical reaction that can carry out by the carboxylic acid. Okay, before we end this video, we still have another part, which is the reducing properties of the methanoic acid. So means that the methanoic acid able to undergo oxidation. Why this can happen? Well, in the beginning of the chapter, we just mentioned carboxylic acid only can undergo reduction but cannot undergo oxidation. Because of when we focus on this is the structure for the methanoic acid. This is the structure for methanoic acid. And then like we mentioned previously at the intro, this part looks like the aldehyde. And this part looks like the carboxyl group. So because of this part is the aldehyde group, so they can able to undergo oxidation. So then we try to recall back in the chapter carbonyl compound. Aldehyde can react with the CmNO4, okay, to form carboxylic acid. But because of for the this one already is carboxylic acid, so they will form carbon dioxide and water. So Torrent reagent will give positive towards all the aldehyde, so will also produce carbon dioxide and water. Only the side product is the difference. So if you use CmNO4, maybe you will be able to see the brown precipitate and the purple color of CmNO4 decolorized. However, if you use the Torrance reagent, then you will be able to see the silver mirror. So basically, this is a very small part. Just want to get your attention that methanoic acid, even though it consists of carboxyl group, but at the same time, part of the structure has the like carbonyl aldehyde group. So that's why they can undergo oxidation and form carbon dioxide and water. Okay, let's continue with the last tutorial question that we're going to discuss in this video. Question number 10. A hydrocarbon AA with the formula C4H8. So then we can come out with the formula CnH2n. So when there are two conditions that the compound can have the general formula CnH2n, one is cycloalkane and then another one is alkene. So how we going to decide? We have to read the information. Does not decolorize bromine in the dark. So from this statement, we know that the C4H8 is the cycloalkane. So then, however, AA react with chlorine in the presence of the light will produce zinc, white film, and single monochlorinated product BB. So from here, then it is very confirmed that cycloalkane, the AA is the cycloalkane. Okay, but then here, when there is the cycloalkane, so we have another two possibility. Is this a methyl cyclopropane or cyclobutane? So another keyword over here will help us to identify single monochlorinated product. So we confirm that the BB is the AA is the cyclobutane. Okay. Okay, because of I already roughly read the question before I start, here we have the part explain your answer. Okay, so then now basically we already starting to explain the answer. So first we can mention that AA is cycloalkane because just copy the statement does not decolorize bromine in the dark. Okay, so here one mark, and then another one mark we will say AA is cyclobutane. Okay, now we confirm because single monochlorinated product is formed upon reaction with chlorine in the presence of light. So you will also notice that all these answers are the one over in the question. Okay, you can see does not decolorize bromine in the dark. Does not decolorize bromine in the dark. All the answer basically is in the question. Chlorine in the presence of light, single monochlorinated. Single monochlorinated, chlorine in the presence of the light. Okay, then don't forget we draw out the structure first. Okay, this is the AA, another one mark. So this statement, cycloalkane one mark, the structure one mark, cyclobutane one mark. Okay, then next one they going, okay, so we need to we need to draw the structure BB. So since BB will be cyclobutane and then one of the hydrogen replaced with the Cl. So BB and the structure of BB another 1 mark over here. Then next they say we will treat the BB with the magnesium powder in dry ether to form Grignard reagent CC. So this one nothing to explain because we already know the structure BB and the question also let us know it will form Grignard reagent. So we just need to draw the structure. In front the Cl we add in the magnesium. So this is the structure of CC, another 1 mark. Okay, because here we know that we need to give the structure of AA, BB, CC, DD, EE, FF, and HH. So then next carbonation of C will yield DD. So then we know that carbonation, we try to roughly imagine. If there is carbonation, means that react with the carbon dioxide. Double bond O will break the bond, become single bond. Break the double bond, form 2 new single bond. So one single bond which next to the oxygen will become the MgBr. Okay, and then the other part we will bonded with the cyclic compound. So this is the structure for the DD. Okay, so we will stop at here and continue at the next slide. Okay, we stopped at the DD just now. So we can continue with this statement. Dehydration of BB produce EE. So this is the structure for the BB just now. And then dehydrohalogenation. So basically means remove the HCl and using the KOH in ethanol. So we're going to produce the EE, which is the alkene. So here 1 mark. Okay. How we can confirm that EE? Because they say we'll give the positive Bayer test forming FF. So if Bayer test, we are going to use co-alkali KMnO4. Alkali is the OH negative and then co. So we'll break the double bond, form 2 new single bond. Both new single bond bonded to the OH to form diol. So this is the structure for the FF. And then here mentioned that ozonolysis of EE will give single product HH. So let's continue over here. So break down the bond. So we will have 4 carbon. And then the first and the last carbon, the double bond will bonded to the oxygen. So complete with the hydrogen, CH2, CH2 here, CH. So this is the structure of HH. So we have another one. Okay, so basically we already predict the structure. And then don't forget we need to do the explanation over here. So what is the things that we can explain? So you just need to let us know EE is alkene. Okay, EE is alkene because this one BB undergo dehydrohalogenation. So again, you can see that the word dehydrogenation is the one that you get from the question as well. Okay. Or you may say that it will give positive towards Bayer test. So you can sambung also here and give positive result towards Bayer test. So EE is alkene, is another 1 mark here. Okay, so then you will say lah, FF is diol, which is the product, of positive result of Bayer test. So diol, another 1 mark here, and then the HH. So you will tell that HH is carbonyl compound which form due to the ozonolysis. So where you can get the word ozonolysis? Also from the question, ozonolysis. Okay, so we stop at explain your answer here. In next video, we will continue. Sorry, not at next video. In next slide, we will continue with another part of the question. Okay, so just now we already finished up to here. So now we're going to start with here. Suggest a reagent to convert EE to GG. Okay, EE just now is carbonyl compound which have C double bond OH. C double bond OH. So and then want to form dicarboxylic acid. Means that is aldehyde become carboxylic carboxyl group. So here is CH2, CH2. So we know that this is the oxidation process. So we're going to use hot acidified CmNO4. So and then the C double bond O will become C double bond OH. Sambung CH2, CH2, C double bond O. So again the oxygen which is undergo. Then therefore deduce, we already suggest the reagent 1 mark, and then we deduce the structure GG another 1 mark. So write the chemical equation to convert EE to FF and EE to HH. So I think basically in previous question we already, in previous slide we already write it down, but never mind, maybe it is not complete. So we start from here. This is the EE, and then react to Bayer test. So we'll form OH, OH plus MnO2. So this is co-alkali CmNO4. Okay, so I think here you need to mention ground precipitate. So this equation, another 1 mark. And then we have another equation which basically I think the keyword over here is this reagent. And then EE to HH, EE is the cyclobutene, and then undergo ozonolysis which is O3, zinc H2O, and then will produce the aldehyde. So 4 carbon, double bond OH, CH2, CH2, double bond OH. So this ozone and followed by hydrolysis will have another 1 mark. Okay, so basically we already finished for chapter, discussed the tutorial question for chapter carboxylic acid. However, not finished yet basically. We are still in the chapter of, we still have the objective question. So in next video, we are going to discuss the objective question for the carboxylic acid. So that's all for this video. Thank you for your time and see you in next video again. Bye bye.